Okay, hi there. This video is going to go over some content on ratios that you discussed in your SI session today. So this would have been your third SI session for week one. So these are a couple of questions that your SI leader asked me to go over, saying that it just didn't seem like you guys were quite understanding from how they were presented there. So I will do that, and then I will do a second video based on some student questions that emailed in wanting me to go over some more ratio word problems from the slides today. I don't do mine exactly in the same way that they were presented by your SI leader. Not that her work was wrong by any means, but this just will give you a different perspective. She analyzed a lot of patterns between the ratios and tried to then use those to predict the next relationship that they were wanting, and that is definitely a strategy. I tend to be more algebra based where I will set up an equation and then substitute or eliminate. So I do a lot of systems of equations for other types of problems, even though we're not really in the systems of equations section. I find that systems of equations are really helpful to just help me solve lots of math questions in general. So you'll notice that as I go through these today that just my methodology is a little bit different. Okay, so breaking this first one down, they tell you the ratio of x to y is 1 to 2. So x over y is equal to 1 over 2. And then they want to know the ratio of 2x plus 3y to, so I'm going to divide x plus 4y. Okay, so I'm going to take what I know, and I can cross multiply. That's a technique that works here because I just have one fraction on each side of the equal sign. But some students get confused on when they can cross multiply and when they can't. And if that's ever confusing for you, I'm going to show you a strategy that would work all the time, just clearing out your fractions. So the least common denominator for this equation is 2y. So if I multiply both sides by 2y, then I don't have to worry about whether I can cross multiply or whether I can't. I can just treat all equations that have fractions the same way, so that might be easier for you. Those y's cancel on the left and those 2's cancel on the right, so this leaves us with 2x is equal to y. Well, that's really handy. I want to show you that that could come out more complicated than that. So another example, you could end up getting like 2x is equal to 5y, and that just makes it a little more challenging. In our case, knowing that 2x equals y makes it really easy, because then I'm going to come over to this part that I want in green, and I'm just going to make a note to myself that every time I see a y, instead of the y, I'm going to write 2x, because I know that that is an equation that's true based on the fact that they told me the ratio of x to y is 1 to 2. So this worked out really well that it was already solved for y, and I can just take that and plug it in. But say I got something that was harder and it wasn't already solved for y. Well, then at this point, it's my choice to choose to solve for x or to choose to solve for y. And it's not going to make a difference one way or another. So I could divide both sides by 2 and get that x is 5/2 y. So then every time I see an x in the fraction that I want, I'm going to replace that x with 5/2 y. Or I could just as easily solve for y and get 2/5 x is equal to y. And then every time in the fraction that I want that I see a y, I would replace it with 2/5 x. So I just wanted to show you that this method does work even if your algebra comes out more complicated than that. You just have to take the time to solve for one of the letters before you plug in, where this particular example was already solved for the letter that we wanted. So then I come down here to what I want, and so that's really equal to 2x plus 3 times the quantity, and I'm going to put in a 2x there, that purple quantity, over x plus, and instead of 4y, I'm going to do 4 times the quantity, and I'm going to put in 2x. So 2x here and 2x here. And so then that means on the top I have 2x plus 6x, that's 8x, over x on the bottom plus 8x, that's 9x. Notice that those x's will cancel or reduce with one another, And so my overall ratio is 8/9. The ratio of 2x plus 3y to x plus 4y is 8/9. Okay, next, this one is a word problem. And it took me a little bit to make sure I understood what your SI leader was meaning by all of these P's. But in looking at her work, here's a different way of kind of breaking that down and thinking about it. Number of coins of each type. So say that X is equal to the number of 50p coins, and really that's the number of 50-cent coins. From looking again just at her solution, I do think the DAT would be worded a little more clearly to either tell you like quarters, nickels, dimes, or to say a 50-cent coin, a 25-cent coin. And then let's let Y be the number of 25p coins. Again, that's the number of 25-cent coins. And then Z is going to be the number of 20p coins. Again, that's the number of 20-cent coins. I apologize for my terrible handwriting here. A stylus doesn't work on this touch screen, so I'm just writing with my finger, but it's not the best. Okay. So, I'm going to get to the ratio part here in a minute, but I think just understanding the money piece. So if I know that the total amount of money is $510, being very clear how you define your variables. This X and Y and Z is the number of. If I want to turn the number of into the amount of money, then I would have to take, so the number of 50-cent coins times 50 cents. So 0.5 times X plus the number of 25-cent coins times 25 cents. So 0.25 times Y plus the number of 20-cent coins times 20 cents. So 0.2 times Z. And that is going to total $510. This is our dollar equation. Okay, now I'm going to get into the whole ratio piece. So I know that my ratio of X to Y to Z is 2 to 3 to 4. So let me switch. X to Y to Z is 2 to 3 to 4. And I need to figure out what my base quantity kind of is, basically. So if I could figure out this base quantity, then X is going to be 2 times that base quantity, and Y is going to be 3 times that base quantity, and Z is going to be 4 times that base quantity. Okay. I have seen some sites, books, etc. refer to this, what I'm calling base quantity, or this open box, as the ratio. I think that's confusing because the ratio to me is 2 to 3 to 4. But I need to find a starting place basically so that I can multiply by 2 and 3 and 4 and scale it in the right way, is how you want to think about it. Okay, so if I could find this base quantity, I'd be good. Okay, well, so then I need to take, I know that X is equal to 2 times that, Y is equal to 3 times that, and Z is equal to 4 times that. So I can replace, this isn't really a second equation, but it's a second piece of information. I can take that second piece of information and substitute it up in my original. So, again, this is like a system of equations sort of setup, which I refer back to quite a bit. Okay, so in my first equation now, instead of writing 0.5 times x, I'm going to write 0.5 times this 2 times my box. If this box idea bothers you, you're welcome to create another variable. So we've already used x, y, z. Maybe you call the box A or some other letter that you like. I kind of like open boxes in math problems where I don't know what I'm doing because it lets me realize, it really reinforces the idea to me that that open box could be anything. I just need a place to start, and then once I have the place to start, I multiply by 2 and 3 and 4. So I'm going to leave it, but if it bothers you, call that open box A or B or C or whatever letter you like. But I'm going to replace the x with then 2 times the box plus 0.25, and now I'm going to replace the y with 3 times the box. And then I'm going to replace 0.2, and instead of the z, I'm going to say that that's 4 times the box. And that is all equal to 510. And so then I'm going to multiply that out. So 0.5 times 2, I've ended up with 1. So 1 of the box, sorry, plus 0.25 times 3, so 0.75 times the box, plus 0.2 times 4, so plus 0.8 times the box is equal to 510. If it helps, you could put a 1 in front of that first box. So 1 plus 0.75 plus 0.8, we're at 2.55 times the box is equal to 510. And then dividing 510 divided by 2.55, I get 200. So the box, this unknown quantity, is equal to 200. But I really wanted the number of each type of coin. So I really wanted X and Y and Z. Well, X and Y and Z is found by this second piece of information that we set up. I need 2 times the box, 3 times the box, 4 times the box. So for X, X is 2 times the box. So 2 times 200 is 400. Y was 3 times the box. So 3 times 200 is 600. And Z was 4 times the box. So 4 times 200 is equal to 800. So there are 400, those were the 50-cent pieces. Yep, and then 25 and 20. So 400 of the 50p coins, and then 600 of the 25p coins, and then 800 of the 20p coins. Okay. Let me make sure we answered the actual question that was asked, that they didn't want like some ratio or something. No, they wanted the number of each type, and so we gave them the number of each type. So hopefully that gives you another strategy to break it down. If any of this is still confusing, though, you're welcome to ask me and I can elaborate a little bit more. Again, remember there's also a video where I'm going to do more word problems because you guys had asked for them.